You're listening to NATS FM, the home of distributed systems chat.
NATS FM is brought to you by Synadia, the stewards of the NATS project.
Hey folks, welcome to Season 3, Episode 2. I was going to break out, it's 2025. Why not start a Season 4, Episode 1? And I think the only podcast probably in history to have, one episode seasons. But there we go, let's not do that. Anyway, so here we are, Season 3, as promised, Episode 2. Just myself and Mr. Pietrek today. So how are you, sir?
Yeah, the mini-series are quite popular right now. So, having fewer episodes, it's fashion.
We could book a new trend. Yeah, we could be the first ones.
I'm doing well, thanks. Nice
awesome.
To be here as always. We have quite a few interesting things to talk about.
Indeed, we do. I've got to say though, your microphone setup is kind of sexy. So it's just off to one side. You're looking very cash. Here's me with my mic in your face, almost mouth at this point. But very cool. Hopefully the audio quality is good quality as well, and not just looking at the video. Anyway, right. So where did we get to on the last episode? And obviously that's a rhetorical question. We almost turned the first episode into a multi-part, part one episode, because one of the biggest topics that we always have around NATS is how to, marry up the features from the NATS server to the clients. And it turns into, I think, every developer's nightmare. And I'm going to be really cruel here. Really cruel, because I did this last time. I kept leading you on and then saying halt, and we'll talk about it on the next episode. A little bit of breaking news, though. I'm standing down after this episode of one of the Synadia hosts. So I left Synadia December last year, so December 24, and I'll be standing back and turning into random invited guest onto the show, but leaving you in the capable hands of Tomasz and Byron. So that's the sad news out of the way, or happy news. Some of you might be walking the dog thinking, thank God for that. That English idiot is gone, and we can get back to some common sense, which is fine. So you've only got me for this one. So let's talk about the nightmare problems of clients. So how do we unpick this, Tomasz? So we have the tier one clients, which are, the kind of, let's say, top drawer clients. So what is that? It's Go. Do you want to run through the list?
Yeah, we can go through the list. It's Go, obviously, was most popular client. Then there's Java, JavaScript, Rust, Python, C. We also added Ruby, .NET. And I hope I didn't forget anything.
Did you say Python?
I did say Python. Yeah, it's and we're actually adding more. We have also some second-tier languages as clients supported, maintained by us. And by that we mean that the tier one clients, they all get support for all the newest features, and they promise parity between them. Which is one of the reasons we meet today to discuss those, because there's quite some challenges, but yeah, that's the goal, that tier one clients are always in parity, that they have feature coverage. Obviously, each of them is idiomatic to their own idioms, but they still provide you the same capabilities to implement your use cases and business logic around. So you should be covered with those. However, of course, every language is different. So yeah, that's also almost like immediate segue into what we want to talk about. But before we go there are also tier 2 clients, or rather all other than tier 1 that we maintain. And those are like, for example, the most recent is Swift, which the difference is that it already has core NATS and most of the Jetstream, but it's does not have full parity, and it is maintained and will be maintained and developed, but it might always lag a tiny bit behind other clients, unless of course it will get a lot of attention by our users, customers, and the community, because that's how we mostly decide what's tier one, what's not. The languages I mentioned sounds almost obvious, like those are the languages we use for the most things. But sometimes there are different use cases for some languages, especially in distributed systems and a lot of edge devices, where like Swift, we didn't consider it at all for quite some time. But then we've seen a really quickly growing interest in this. And
so I want to stick a pin in that bit there, because I know where you're going with this. You want to jump straight in and get into the nitty gritty. I'm going to hold you back there, right? So this is my last one. Yeah, so what I want to do is I'm going to wrap a rein around you and just put you in a little bit. So if we think about NATS as an ecosystem, really, it's a stage. I don't want to say platform because it's overloaded, but we have many features that's built into NATS, and then the clients allow us to use those features, and then the clients have their own idioms. There's an idiomatic way of doing something. So somebody in .NET might look at the Go client and go, the hell's this? I don't know why this does it the way it does this, because every language implementation is specific. So then the tier ones, up until this point, have tried to maintain this parity across nine languages, and it's really difficult. So then let's say another feature comes out. Now you've got to add another layer across all of those languages, all of those libraries. And it gets to a point where you just can't maintain that. I don't think and I know where you was going. Like once you start looking and leaning into, say, embedded or super constrained systems where you need a NATS client, the use cases will steer, I guess, what goes in some of those clients. And you can't then just have this like whopping great big parity difference between the clients, because language A is used for A and language B is used for B. It's a balancing act. And I know you wrote a whole blog post on this, and I remember kind of trying to add some more context to it, because it's a really deep, gnarly problem, and everybody views their problem as it's obvious from their point of view, and it's idiomatic or not idiomatic from their point of view. So it gets really, really challenging. And I think then it becomes like almost a logarithmic problem where you add one feature over here, that impacts this one, that impacts that one, and it just scales out of control completely.
It's actually even worse, I think, because the use cases is one thing that drives the client in different direction, but it's not accepted. And I understand it fully, that people are not happy that I was able to do this in let's say Rust, which is often used in low-level stuff, but I really need to do this in Python client too, because I just want to be agnostic over the language if I use NATS. And this causes, and sometimes if it makes sense, it's great. We can just have the parity for them. So in last 2 or 3 years, we changed the approach how we add things to the clients. In the past, we were just adding them as they were needed. For the happiness of the clients or customers or users asking for this specific feature, their PRs were accepted. But it was just a matter of time that every single feature of those was why it's not in the other language. And here's the challenge, because some of those are use cases, and use cases are not that hard because we can actually make them work in all the clients if it's just a use case. It's much different story if it's just an idiom that language has, that it makes sense to do X, Y, and Z, and it makes no sense to do it in other languages, yet it breaks down the parity, and people are unhappy with it because, of course, there's no rationale behind every feature added to the client. So we end up in this situation that for now, every new feature added to tier 1 client has to go through the parity check, meaning all the maintainers have to agree that this goes into all the clients, at least tier 1 clients. And this ends up that we are never happy. Because if we refuse a PR that makes sense for, let's say, Java, which has very specific idioms for how extensible it should be and how many connectors it should work with seamlessly, if we accept this PR, suddenly the same requirement pops up for Go, which is extremely on the other hand side of the spectrum, how you interconnect it with other tools and frameworks, etc. So it sounds like it will be a bad experience across other libraries, but it's also very bad to just not accept it in Java. And on the other hand, sometimes there are PRs that make sense for everybody, and then we go through the process and we agree to add it everywhere. And so this is one side of the coin. The problem is that some feature being here makes full sense here, but nonsense elsewhere. Refusing it sounds really bad. Accepting it sounds also actually bad. But it's only, again, not whole of the story, because there are then situations where there are features that make sense everywhere, like in every client. So it sounds, just guys, accept it and merge it everywhere. But it goes way beyond what a basic client should do. So we turn down something that was useful generally, or accept it and make the code base more complex or opinionated. This is one of the angles of the challenges of having the parity.
You mentioned the coin face, right? So I've got like a heads there. This is an English one pound. I'm going to flip it to the other side, onto the tail side, because I want to argue the other side of the coin. Not for any good reason than just to argue the case and the viewpoints, because context is king. So is this not just a case of a Rust developer using Python in the way of Rust? Let's go down the list and let's go down the angering ones. And is this not a case of, somebody writing Java, but they're a Go developer? And I'm talking through the lens of parity at the moment.
Yeah, that happens too. It's a different struggle, to be fair, which is not connected that much that we want to talk about today, but yet it's relevant. Because there are, I don't want to name them, some other language agnostic technologies that try to achieve parity in some way, and they try to do it to make the APIs as similar to each other as possible. But then the outcome is that when I use them in Go, let's say, and it felt very weird for me as a Gopher. Like, it didn't feel like Go. It felt like some weird mashup of how to get it to specific state. And then I used Rust one, and I said, okay, this is exactly the same, but despite that I cannot use it because I have to once again learn those weird ways done differently because of a different language. So I didn't address what you said directly, rather indirectly, but this is a big challenge of all those clients for NATS, that people do try to use idioms from other languages in other languages when they have a need to. But we try to rather focus on those who know the idioms and know how to use them, and then steer those who don't to the examples and some basically language guidelines sometimes, to focus rather on those who use those idioms properly, because I think this is majority and growing majority in languages. Yeah.
And then, because the coin is multidimensional, I'm going to flip it on its side. And obviously it's circular, right? So it's an infinite side. We can go this forever.
It can happen on the side. Yeah.
Oh yeah. There's one for you. Anybody listen to this? Hey, the side of the coin, it's an infinite. Anyway, the other aspect of this is how the clients ended up trying to reach parity in the first place, given that we all kind of accept at a certain level. I think it's quite a conscious level that certain languages have their place in certain industries and in certain. It's kind of like if I said to you, tell me the first language that comes to the top of mind for machine learning.
Yeah, it will be Python.
Right. What about embedded control on constrained embedded systems?
C or Rust.
Right, C Rust. So anybody kind of going, well, hang on a minute. So you've gone to great lengths to add Jetstream support to, I don't know, TinyGo.
Yeah. Good luck with this.
But yeah, so that's the other aspect. So How did we get to this position where the clients have all tried to have some form of parity? Was that a conscious thing, or did it just happen because the community drove it that way?
I think it was both, actually. The community driving it there was clearly showing that we have some issues. And also our internal discussions at Synadia were showing that we didn't have always the parity in terms of understanding how things should not just parity of features, but parity in terms of how given feature work. So that's why we worked more and more on the ADR process and the design process for each feature to having them better described. So to address both, it was we seen it ourselves, but it was also very visible that it added unnecessary friction. Though it sounds simple, just remove the friction at the parity, but then all the problems we mentioned a few minutes ago arise, and seems like there's no good solution. And to just touch the other topic you mentioned, like there is a jet stream in every client and key value and object store, and they actually just bring more dependencies, bring more problems, and bring more complexity, which on one hand side, it seems great that you just import one client for whatever language you're using and you have everything. But on the other hand side, it makes versioning challenging, breaking changes impossible, even in new APIs. Because you add a new API to the current client, the client is versioned just one time. It's one version for everything. And if we try to respect Samba on the client side, it feels like we never can break anything. We can mark a specific API experimental, but how does it matter if this experimental API is released with the same server? If you would break this experimental API, we probably still should make a major release. And that cost us that we would love to improve some of the APIs when they were early days of those, but we kind of couldn't. So this is another problem that the clients were growing with. As NATS was just core NATS, it was extremely simple. We talked about it in the last episode. And it's still, most of those concepts are extremely powerful, and everything else we built is built on top of core NATS. And I think it's totally understandable why the NATS server contains everything. Because this is a thing which you cannot split into microservices, because then you add tons of complexity for people running it, because they suddenly have to run a plethora of different services. But also it impacts latency and performance, because it's inter-service communication, which would be impossible to reach the current performance limits of NATS, JetStream and key value and object store, if it was not all in one package. But the same is not true for the clients. You can import many libraries for your one application to run it. But yeah, we didn't have a good idea about it for quite some time, how to address this problem, and ended up in having everything in the clients.
So I guess there's a fork in the road now in this conversation. And just in the interest of time, this could turn into a 2-hour podcast, or it could turn into, a 30 or 40 minute kind of good overview. So I'll try and keep this brief. At a high level, before we get into more of the details, what is Orbit and what is not Orbit? So if I throw something out there and I'm going to go down the path of the ridiculous, and you can then correct and then tell me what it is this kind of like where we describe NATS as AWS, right? So you might have an AWS library, you import EC2, you import S3. Is Orbit the splitting up of core NATS, JetStream? Does each set of features become a library, a module, a package? Or is this a line in the sand, and beyond this point, new things, experimental things, custom things, then go into Orbit?
Yeah, it's the latter. And it's the latter rather of necessity than how we would like to do it, because we still don't want to break the current clients. And for now, we kept all the current features in the current clients. So the goal is that from now on, every new abstraction built on top of, because key value is abstraction on top of streams and consumers. Same for the object store. It's not a new, different feature in the server. It's just a client abstraction. Same for the service API. And all new features, abstractions like those will land in orbit. So it's like a line in sand to not break the clients. But that's not all it is. It's actually more. It's also when we add new, and you will see it in 2.11 client releases. That
whoa. Stop that talk. 2.11, okay. You can't just come out and say, well, you'll see it in 2.11. We've already been talking about that for, I don't know. I don't want at least 3 seasons of NATS FM.
That's true.
Yeah, sorry, as you were.
Yeah, the thing is that some of the features that server has, it's fine as it is for the new features, but we are not 100% sure how those should be exposed in the client, because we don't do one-to-one transfer, exposure of the features of the server to the clients, because server does huge amount of work to optimize the work, reduce the network used for given requests, etc., etc. So that means that the API is not always the prettiest. It's very focused on performance. So there might be just one struct for many operations for simplicity and basically optimizations. But of course, on the client side, we want to expose it in a nice way with separate behaviors and separate methods, etc. So this is one of the things that we are also adapting Orbit to, meaning as an incubator for the new features and new APIs, which we are not confident the shape of yet. So even some new release features for the new server versions might be actually first supported in Orbit with the goal to move them back into the client. Because one important thing we didn't talk about, how Orbit is structured, right? What it is actually each client has their own umbrella repository with many crates, modules, how you call it in a language, each having separate versioning. Meaning that we have the freedom, it's not like having the same problem of non-breaking changes in Orbit like we have in the clients. There are many modules, crates, packages that you can have there, and each are moving at their own pace. And we can merge them back. Some of them, they are incubating there for the new client features, or we are not sure how they should look actually. In the past, we would make a compromise and make a safe API in the client that we're not very happy. Not doing it didn't feel great either because people were asking for this. And now we can solve this problem of having the feeling that all the options are bad for the community and users, and just add it as a incubation API into Orbit. And if it matches there, then we can merge it back. So this is one of the use cases that you will see shortly.
So you just completely ruined the segue, by the way. I was going,
I'm really sorry.
No, it's okay. Don't worry. I'll catch up with you in March, and I'll distribute some revenge. I was going to try and quote the line from Lock, Stock or Snatch, I think it is, but I can't do it. And it's like, not only that, it's a bit sweary. So going right to the back of back to the top of the Orbit conversation. When we say what it is now, it's going to be a manifested directory with a set of packages, some incubating, which might go back into or might get merged into the clients. Is this going to be Synadia and NATS community only through the NATS repo, and what I mean by that is like the kind of core maintainers, or can anybody do a PR and say, actually, here's my experimental feature as me, Dave, I want to do blah, and because this is not stable, I'm just going to release it and maintain it myself. Can I do that?
The main idea is, for simplicity for now, that each language will have their own Orbit repository, and we are one of the goals is to make it open to contributors, because sometimes it's not that easy to contribute to the client because of how big the code base is. So we also don't promise parity in Orbit. There are some features that will be in all tier 1 Orbit libraries, like the request menu we added recently, because it makes sense everywhere. But some of them, like the context utility, which is closely coupled to Go, is in Go Orbit and will not be in others. So that opens up the doors for people for having easier contribution, because all they need to do to add new feature or propose new feature is to make a PR to create new module or extend one of the current ones with the only knowledge necessary being, I know how to use the client, not how to you don't need to know the machinery of the client itself, which is a more complex beast. So we also hope that, and we also see it already, that people are proposing they get a lot more, ideas throwing at us at Slack and elsewhere. Oh, we could add this and this and that. And they knew that we would, disagree to add it into the core clients. But now with having this more freedom there, we see a lot of more basically ideas thrown at us or there. There are not that many contributions yet, rather ideas thrown on Slack or elsewhere. But that's a good start, and that's one of the goals of Orbit is exactly this: to make contributions easier and being way less effort to start working with them, because you can start with just clean state with new extension and just build on top of a client API.
So that raises the next question then. In terms of the release cadence for Orbit assets, is this going to be is there a separate Orbit repo per language?
Yeah.
There is. Okay.
A separate Orbit repo per language, and each repo contains many modules, crates, packages. So each of those packages have their own release cadence. If it's quickly evolving APIs, those can have releases even weekly. If this is something pretty simple and stable, it will just sit there for some time, and we'll decide if it's sitting there because it's a simple extension but it gets some adoption and usage, and we can see it at each module how it's used by statistics of each language, downloads, etc. We can make it stable, or if it's not used, we can also just deprecate it. That's fine too. If it didn't call to the wind at all, that's also fine, which was never fine in the clients, because again, that would be a breaking change.
Interesting. So next question then, and I no doubt you've also got a load you want to talk about, but you kind of lit my brain up with lots of interesting, or maybe really dumb points. Some people have been listening to this going, here he goes again, I'm glad this guy's going. In terms of the coupling between so I'm going to talk about this through the eyes of a gopher, because that's the language I know best. So if we take the Go NATS client, and then we take the Go Orbit, whatever, repo, because it's going to be separate modules in there, maybe.
Yeah, let's say Orbit repo,
yeah. Okay, so we take the Orbit repo. What's shared from the NATS client library into Orbit? So is there a bunch of interfaces, a load of data structures? Because obviously that's going to be, if so, that's going to be tied to the NATS client version.
That's a good thing, and this is actually advantage that about eating your own dog food, right? Mm-hmm. We wrote a bunch of code for each of our clients, not just the clients. Hundreds or rather thousands of tests for each client. Bunch of examples from NATS by example, etc. But we never actually try to write SDK on top of our clients. And that's what actually many companies do, because NATS can be treated as pretty low level. So companies want to develop some abstractions that make things maybe not easier, but easier to be consistent across teams, etc. And in Orbit, we just use public API of the clients, because that's the only way we can do it. It's separate dependency. So we find out quite a lot of things in the client that should be exposed and are not for flexibility. And that's the answer. At the end, we are just using the client public APIs, and we learn along the way that we didn't expose some really important bit to be able to write really flexible SDKs on top of it.
That's really interesting. So even last year, I ran into this where I tried using a public API in the NATS client. And I don't know whether it was a bug, but it's been there so long, it's now a feature. And I think it was in the request publish function. And I thought that you could generate your own inbox. So go to the server, get an inbox, and pass it into the function, but you can't. You literally pass a struct in, and it overwrites it. So what I'd like to do is listen first, then do the publish, but it didn't work, and I ended up then doing a diff on the client library to try and fix it. It's a long story, but I was thinking, oh damn, okay, so just in the very act of trying to use the publicly exposed APIs, that it was an exercise in torment but revelation. And the nice thing you mentioned about the dog fooding earlier, it kind of prevents you from doing the other thing that dogs do, which is not eat the food, but they eat their own the chocolate milkshake emojis. But it's a tale of two sides of the sword, It
is. It is, and that's we are always very careful with exposing any internals because it makes evolving the clients even harder because you have more things you could break by changing them. So we are very always, conservative there. And users were sometimes unhappy with it because they wanted to do more. But we didn't know what we should expose because the only way to learn it is to have to use it and add those things.
Yeah. And now when
we are wrapping the clients with additional features that are able only to use the actual public API, that shows a really good, it gives us a really good way to judge what's actually needed and what not. And the Go is a good example when we're now trying to do batch get, which will be the 211 feature that we decided to get it into the orbit instead of the client. Not because of it being unstable on the server, but rather that we didn't know how to shape the API really well. And after many discussions, we said, okay, if you cannot agree about this in a few weeks, it probably should be experimental for some time and then incubate. But a lot of clients found out that it actually means that we don't have quite a few things exposed in the clients. And we're like, it really should be exposed. So we are not starting exposing everything. We just, whenever we see a need to expose something, we now have a really good justification.
So quick question there then. So let's say Orbit feature X is in development and some of the public APIs, they don't they're not available. So the thing that I need is not being exposed, but I know it's in the low level NATS API, the NATS server API. So what's the right way of approaching this? So for anybody listening to this going, hang on a minute, this sounds familiar. Is it to implement what you need via the actual wire protocol to get the NATS server to do what you want to do, and then maybe write it up, and then hint, it might be good to have this actually in the official client to then expose it as a public API? Or is it just to implement it in Orbit to go straight through the NATS server and just leave it alone and walk away? How do we do this? Because obviously this is a community thing as well.
Yeah, we never try in the Orbit to use the wire protocol directly. Because as we talked in the previous episode, if you didn't see it, just go watch it. It's everything in NATS is built on top of CronNATS. So, and we went at length last episode to talk about it, which means that if you have access to publish and subscribe, it is a simplification, but just a tiny bit. You can do basically everything and build any abstractions you need. And the same applies to Jetstream, though there are some very common patterns like Jetstream request, which has typed responses on errors and proper success responses. that clients started to expose, which has additional value that we realize that if we expose this and use it in Orbit ourselves, we also allow people to build their own additional like admin API that is not exposed in the clients, which is actually now exposed in the Orbit of Go. So that's the idea. Never wire protocol unless you mean by this to just use directly publish and subscribe. Or we try to use as high level abstractions from the client in Orbit as possible, but we can always go one layer down into PubSub where it's hard to imagine we might not be able to do anything. And that's probably the answer. Depending on wire protocol feels a bad decision, to be fair.
Let me rephrase. Yeah, what I meant was the wrap PubSub handlers. Yeah, because obviously the wire protocol is basic, but why do that when everything's wrapped for you? Yeah, so sorry, I meant the next one up. Obviously, it's tilts all the way down.
Okay.
Yeah.
So PubSub is often used, but it's like some of the extensions like request many. So you can send a request and get many responses, and we have many strategies to when to decide when to stop. One of them being how many messages you expect, other being the jitter. So what's the difference? Or the stall time, how long you expect to wait for the next message, and if there are no messages, you stop. There are a few other strategies which are useful in different use cases. And this is written on top of PubSub because this is core NATS extension. Most Jetstream extensions, we are able to rely on actual Jetstream methods, which we have in the clients, most of the time at least. Though if you look at the Jetstream implementation, the clients, after all, it's all still PubSub and core NATS. So the answer is it's mixed. It's mixed. It's depend on the feature, but most of the time it's not going more than one layer lower to add this abstraction than the current one. And if it's more, then probably the API of the clients needs a bit of improvement in terms of what's exposed.
Okay, cool. Right. So Orbit today, what's the general state of it across the tier 1, tier 2, and tertiary language set? So what's the coverage right now?
For now, it's tier 1. The most amount of modules are in Go. And then it's followed up by Java, Rust, and Java and Rust and JavaScript. Those are the most advanced ones. .NET, C, Ruby are following it up pretty soon. So the number of utilities is also different across each. In Rust, there's for now only request many, though in Java there are like 3 or 4 other utilities, which is a good example because Java is a very specific language in terms of how it addresses extensibility and expected features. So,
really? I just thought you threw a factory at everything.
Yeah, but you need those factories somewhere. and yeah, that's what we actually added, some utilities like a publisher factory. So which does not make sense in Go or Rust, or rather people get angry at you if you added those. Yet it makes sense in Java. So Java has few quite Java specific things which are not related around new features or abstractions, but rather expectations from Java community. Same for, and no, that's only true for Java. For Go, there are more extensions because the server is in Go, so you can do, and CLI is in Go, so you can have some additional tools that allow you to use the Go context or a few other stuff. So the state is, it will never be a parity. The only thing that is expected to be everywhere for now is the request many, and more will come for sure. But that's so it's the request many across most of them, and if not there, it will be there very very quickly. And bunch of smaller utilities that were, some of them were already in the NATS ecosystem, but there were some like in JSM of the JSM repo that almost nobody externally uses, and it was hidden very deeply. I didn't even know it existed for the context. So even Synadia employees had no idea, and now it's way more visible. Those are the useful things you can do.
Nice. So, given then, where are we? Season 3, episode 2. It is the 4th of February. How long has Jetstream. No, David. Orbit. How long has it been out for, and how long has it been in the wild for?
That's a great question. I have no idea. Because we are talking about it for quite some time. And we started discussing it after the service API was released. Because we were actually not very happy that the service API was in the clients, because we very quickly felt that we couldn't break the API. And we just were stuck with all our decisions. But we at this point, we have an idea to not put more things in the clients, but we didn't have other place where to put it. It didn't sound good to create a new repo for every new thing you want to add to the clients, because the community would be totally lost with all the cluttered things multiplied by number of the clients. So then we came up with the ideas of Orbit, meaning a umbrella project for each language where we can put which would be a home for all those things we cannot put in the clients, because incubating, because extensions, or otherwise. So the idea was starting to grow on us since service API, and we figured it out, but we didn't actually implement it. Then there were some features. Java was first with this producer thing, and then the request menu was something that happened for every client. So sorry, no concrete answer. Can't remember, but that's
while
timeline. A while.
Awesome.
It took us a while together.
Yeah, I recall some of the conversations. And in fact, I think I remember running into this brick wall myself. I was trying to do some PR against the services API on the Go client, and it caused a bit of a ruckus, and ended up having to delete it. But obviously, Orbit would have been the answer to that. Now, next question: when we have natural progression of NATS, so these features coming into the KV, this still goes into the core client, right? This is not now new features going into Orbit.
No.
Where's that line?
Okay. So for abstractions, it's simple. It always will go to the Orbit. For non-parity items, that makes sense. It will always go to the Orbit. In terms of supporting 2.11, the only moment when it does not go into the client is when we are not confident about public API in the client, because the server API is public and it stays forever since the 2.11 release. So it's about, we feel that some API we didn't figure out it entirely, so we will put it in Orbit as an incubation, and it'll go back to the client when it's mature. So most features will come directly to the clients, because I think the important thing is to now we have a clear line. What's the goal? Like, the client goal is now to focus on performance, stability, and resilience. And core NATS and Jetstream plus key value and object store, at least for now, support. And nothing more. Everything else, every experiments, which we couldn't do properly before, now we can. Every new abstractions, every new APIs. New APIs meaning built on client-side abstractions built on top of current features will land in Orbit. Clients will focus on, again, stability, reliability. And it also will allow us to make them more lightweight in the future, because many things we add in the extensions we do, they also drag with themselves some dependencies, which not every language is really good at sorting out if it's not used by the user. So I think that's the line. We would love to, strip the clients from almost everything to make them really minimum, like a low-level wire protocol binding almost. But of course, we don't want to break anything. So basically we've frozen the clients with the feature set at core NATS JetStream key value object store, and we are only extending those APIs by making them able to use newer server features. Everything else would go to the orbit again.
Okay, that makes sense. So I guess, even just to kind of like validate some of this thinking, that if the services API didn't exist and it was going to be built today, where would you put it? Would you try and get it in the core? Yeah, orbit. Yeah,
it'll be orbit because it's abstraction built on top of core NATS. And I will give a good example. In 2.11, there is a feature called priority groups for consumers, which has pinning and overflow. I'll not go into details. We'll have a separate episode about it.
Thanks.
But one thing which is important, that pinning allows you to have consumer groups, Kafka-like, but you need few more details and moving pieces in to have it working. So what we did, that the pinning and overflow will be supported in the client as a basic, useful but basic concept, but the actual whole consumer group abstraction implementation will be in orbit, and we'll iterate over it probably a few times. So that's the example. The client got the support for the new server feature, so you can build things on top of it, but those things that we are building on top of it will be in orbit, not in the client.
Yeah. And just as a hint for anybody listening to this going, "Ooh, that sounds interesting," I'm only going to suggest this, but you have to get the French hero himself on to talk about that.
We will get the French hero to talk about it.
Yeah, J&M, awesome stuff. Anyway, we are at time. So this has been awesome. Thank you for this, and thank you for putting up with my ever series of stupid questions. It's been awesome. And this is my, I guess, final goodbye. Well, not final goodbye. This is my goodbye.
We'll get you as a guest.
As a
more time
co-host.
than you like to.
Yeah. Well, thank you for this. This has been an absolute pleasure. And I look forward to joining a guest at some point. And all the other stuff I've got to say.
You're still using NATS after all.
I was just about to say I'm never going to get rid of it. That sounded awful. Yeah, I'm now turned into a heavy NATS user as opposed to trying to hawk NATS by day. I'm now using it by day again, just very heavily. So I'll be annoying everybody on the community before too long. But yeah, NATS is very much staying with me.
My way was the other way around, from heavy user.
I was a heavy user before, and then came in.
True.
But I was a Stan user, not the. I wasn't JetStream era. Yeah, so it's all good fun. But no, I'm kind of back to my roots in networking. So mobile core, virtual mobile core, Go, NATS. It's all good fun. So yeah, I'm back doing concrete stuff, which is kind of nice. Anyway. Thank you, folks. Like I say, Series 3, Episode 2. We did tell you there'd be more episodes in Series 3. It wasn't a lie. So there you go. So thank you for listening to this. The links are going to be in the show notes for the previous episode where we talked about basically core NATS, the pub sub stuff. And there's some other things that Tomasz mentioned as well. And we'll try and get some links for Orbit directly below. Quick last question. Are there any good examples that people can follow for Orbit for their favorite programming language?
I think the best way to actually just visit the repo for a language because it's self-contained. And the thing is that the repo will give you the list of all the extensions, and each extension is a separate README page. So you can have nice overview of what this language Orbit provides you, all the extensions with given versions, doc states, and all of that. But then when you click through it, you will get into this, specific extension with all the details, all the docs, and all the examples. So probably looking just by the names of the extensions in your favorite language, you'll very quickly pick your favorite, and then inside you should see a lot of docs and examples and ideas you can have about it.
Cool. Excellent stuff. Well, that's it then, folks. Thank you for listening, and I guess we'll catch you next time. Cheers.